Hello, and welcome to my second video on the teardown of the Furuno 8111 radar. So, behind me, I've got the tethered remains of the scanner unit. Torn apart the antenna, so that's my next video. But we're going to hit the display unit right here. This is actually display and processor. All the smart stuff goes on inside of here. I gave it a good going over with the screwdriver before I did this video, so it should go a lot faster. I don't think y'all want to see me, backing screws out of things like I did in the earlier video. You learn as you go along. So, but let's have at it. This thing's pretty old, and the trackball is messed up. It's old, but it's a CRT. Good old picture tube. And I'm going to start off this thing. There you go. Now let me remove this. Come back to this guy right here. That's what happens when you pre-take things apart. So I'm going to start off where the power comes in back here. It goes between 24 and 32 volts input. It's got switch and supply. So the first thing that we're going to do is look at the filter. First purpose of this guy is to filter out noise from inside the ship and to prevent the radar from interfering outward. So you don't want anything to interfere with your radar, and you don't want your radar to interfere with anything else. So you have a filter. And that is connected from the switch and supply board. One more screw. Alright, there you go. There's the filter board. On the back is the terminals where you bring in your 24 volt DC. You got this little capacitor here. What value is that guy? 47 microfarads, and that's just going to take care of the high frequency hash that's on the line. Then you got this big honking high current inductor right here. It's kind of overkill for the winding, but it gets the job done. And then you got yourself a diode. I'm sure that this diode right here is to prevent reverse polarity from messing up the radar. Blow the fuse. You got your fuse right here. Couple of little capacitors. So that's all it is. It's resistors and an inductor and some capacitors to filter out all the noise. So this acts as a barrier for noise on the power line. So the next stop is the switch and power supply. Okay, all this. And that guy's right here. You can see pretty much connects everything else inside the radar. It's the heart of the radar, really, when you stop and think about it. Got a nice big honking heat sink on the back. Even though it's a switch and supply, which is totally on, totally off per se. You still got resistance in the output transistors. You got all these little custom modules right here that's coated in epoxy. Got inductors. Here's a transformer, and what the switch and supplies do is they'll chop the DC and turn it into AC. And it's a much higher frequency than would normally have with your line voltage, line current coming into your house. You got 60 cycles. If you got a 200 watt supply, power supply, it'll be big. You're not going to pick that dude up if it was 60 cycles. But because Guess you could pick it up, it's just heavy. But this is about the size you would expect with about a 200 watt power supply, switching supply. This guy right here was probably running at 40 something kilohertz. That's my guess. So, pretty straightforward. I'll be doing a video on power supplies later on. And, you know, I'm going to be pulling out of a bunch of text. The material in the text really gets over the head of your average technician, so I'm going to digest it down and, you know, try, see if I can't get it to y'all. It's not hard. It's not hard to understand, you know, if you're going to be troubleshooting things. If you're going to be designing them, yeah, it gets kind of crazy. So here's a high voltage power supply. This is the power that goes up to the scanner. It goes to your modulator board. And you got, of course, the transformer right here. This combined is a pulse forming network. And then it goes to your magnetron, which makes your, you know, RF energy that comes out of your radar. The wire that comes out of here, you see it's orange. When it gets into the control cable going up, it's usually brown. And then at some point inside the scanner, the larger radars, it turns orange again. Luckily for us, it's all connectorized. So you just disconnect connectors and reconnect them. Not have to really worry about the colors too much. The output of this power supply is about 500 volts. It's not a huge amount of wattage. But it's a 500 volt supply that goes up into the modulator and it gets boosted to a couple thousand volts. I haven't looked that up. You really don't pay too much attention to it. I mean, when you're checking a radar, you look, and I got a cheat sheet. So when I look at the performance, the self-test of a radar, I go by a cheat sheet, and I never committed to the memory. All right, so now you got your CRT right here, your cathode ray tube, your picture tube. Now, what you want to do whenever you play with a CRT is you want to discharge the anode. So let's short it out. I'm using 2 screwdrivers. Very straightforward. You come in here, you undo it. You know, you're not going to, unless you got a heart condition or something, you're not going to get killed if you get shot by this. It's going to hurt bad. And it's pretty lousy to find out you got a heart condition, you know, out on the ship. So here we go. I'm taking loose the connection to the CRT, and I'm gonna come from the back. I'm gonna take the screws, the last screw loose. And you see, what's typical with Furuno is they got these little grommets, these little rubber grommets all around where that you go in to make your adjustments with your CRT. You got all these adjustments right here. You got a little hole going through the back. You got a grommet, these little rubber grommets, and that prevents you from shorting out the circuit. And in reality, you really want to go into these things with a insulated tool. They're kind of hard to get nowadays since, you know, this stuff's going out the door, it's all obsolete. But here's a power supply for the, this part right here is kind of, well, it's a mix because this not only provides the high voltage for the transformer, it also provides your horizontal sweep. Here's, I'm assuming that this is the switching transistor for this. That's called a flyback transformer. You know, not a lot to it. It's you know, years ago you had a lot to deal with. Now it's much smaller. You've got integrated circuits that do most of your work. And with this guy right here, I condemned it because I measured all the voltages coming into here. This guy should have been making high voltage. I went and checked the high voltage at the anode cap, and there was none. At that point, it's over. It's obsolete. It's not worth fixing. Something's wrong with this board. There's nothing to blanket, nothing like that. You crank up the brightness all the way. You know, it's your contrast, you put brightness, contrast. You don't get any kind of flooding, no voltage. It's gone. So here's your CRT. In fact, I'm gonna pull this guy out. You know, you don't see CRTs that much anymore in marine electronics. You know, they've been superseded by LCD displays for a long time. They're still out there, but if you're an aspiring technician, if you're looking to hobby, and you decide you want a really high performance oscilloscope, you're not going to go and buy the latest and greatest. They're incredibly expensive. The prices have come down, but they're really expensive. So, you're going to go and buy something older. With a CRT in it, you can get a huge amount of performance, high bandwidth, everything else, for very little money if you've got a used CRT scope. Alright, almost there. So, it really pays to understand CRTs, because if you get one on eBay that says, it doesn't work and the person's being honest, you get it at a good price, and you repair it. Or you got your scope and it's working beautiful, I mean, just right on the money. And then the CRT circuit gives you problems. Well, you're going to cry. You're not going to want to throw that thing away. You go on eBay, you buy yourself a parts unit. Maybe you buy some new parts for it, if you think ahead, and repair it. Alright, I guess there's a static conductive tape right here. Looks like it's metallized. Furuno really does some good work. They really think that thing through. So here is the CRT, the pitch tube, right here. You got your anode cap right here. You really don't want to touch that thing if it's sitting here open. It's, the air blowing past will charge it up, and you get a hell of a shock off of this guy. And this is a voice of experience. This is the deflection yoke. And inside there you can see what they call the gun. Later on, I'm going to make a video on CRTs, well, vacuum tubes in general. The likelihood of you working on vacuum tube equipment is almost nil, but the knowledge that you get from that will help you in other ways. Now, I'm going to correct myself. There is a chance you work with vacuum tube equipment. Got your friend of Magnetron. This guy is a vacuum tube. When I worked at Channel 6, the vacuum tube transmitter went out the door while I was there. Huge assembly. And we replaced it with a Log-N solid state. If you're working in television, go to work in television, chances are you're not going to see a, well, if you got a VHF in your market, you're not going to see a tube type transmitter. But UHF, when we went to the digital television channel, when we got our DTV in, it had 3 IOTs, inductive output tubes, klystrons. So it had 3 vacuum tubes in it. So yeah, if you're going to broadcast and you're doing radar, stuff like that, you're going to come across it. You're not going to come across the vacuum tube audio amplifier unless you're into audio or anything like that. So, vacuum tubes is what it is. I'm going to stop rambling. On. Alright, this is a processor board. This is the heart of the radar as far as its brains go. The power supply is the heart that pumps the fluid, the electricity, the juice, and this is the brains. Here we go. It's all surface mount. All the way through whole components are these EPROMs, erasable programmable read-only memory. There's a little window on top of this thing that's covered up. You can erase it with ultraviolet light and reprogram it many times. So that's how you upgrade things of this vintage. You got a prom right here, socket mounted, well held down with a clip. That's typical Furuno. But you got quad flat packs, stuff like that. I started to research the processor itself, looking up parts and all, but I don't know if you can see it on the camera, but it all says Furuno. It's all got Furuno part numbers. You get limited information on it out of the manual. This really isn't designed to be serviced by anybody other than Furuno. But on the flip side, you can service these things. You can't get the factory chips, but you can get almost everything else. Almost everything else has part numbers, and the service manual does give you a rudimentary schematic. You just got to think about it. But the chances of you troubleshooting with these things to the component level, nil. So this processor. This has the display section in it. It also has a synchronizer. I'll be covering that a little bit later on. Not the next video, the one afterwards. So now what we have is a shell. It's all out here. As you can see, there wasn't much here. Wasn't much at all. And your clamps back here. Now, a note. Marine equipment typically has nice clamps. They'll either have this. Furuno's uses good metal clamps. Other ones will use a CGB. That's a cable gland bulkhead. You screw it down. You really need to clamp these things down in the field. When you're installing this stuff, you really need to make sure it makes really solid connection in there. So somebody's in a console pulling around or something like that, they don't pull out. In many occasions, you will bring the shield of the cable back around and clamp it down inside of there. And every radar comes with a little roll of tape. Well, the big IMO ones. They come with a little roll of tape, little tape. You use that to take up the space. If you got to take up the space and bring the shield around, you take the space underneath it, bring the shield around. If you're not doing that, you just take it up but you want a good solid connection there, physical connection. Well, my next video I'm going to talk about the antenna, the rotary joint, stuff like that, and then the video after that I'm going to talk about what's going on inside the processor from a general standpoint. There's no way that I can get into the theory behind this thing, even if I got a good theory of operation to work from. It's beyond the scope of these videos. So I'll see you in the next video. Thank you.